Welcome to Get Your FRQ On. This question is from 2017. It is question 6, and it is not calculator active. In the question stem, we have 3 different functions being defined. Function f is defined with a rule. Function g is defined with a table, and we are also provided values of g prime, 4 values in the table. And we have a function h, which is defined graphically, and the function h consists of a handful of line segments. In part A of this question, we are asked to find the slope of the tangent line to f at x equals pi. F is the function that is defined as a rule, so to find the slope of the tangent line of f at x equals pi would require us to find a derivative for f. F is the function cosine 2x plus e to the sine x, applying differentiation rules. F prime of x is negative 2 times the sine of 2x plus cosine x e to the sine x. And if we want to know the value of the slope of the tangent line to f at x equals pi, we need to evaluate f prime specifically at pi, which would be negative 2 times the sine of 2 pi plus cosine of pi times e to the sine pi. If you simplify this, you don't have to for this one. This expression right here should be sufficient since all the calculus is done. However, if you do, these are all going to be exact values, which you hopefully remember from the unit circle. And when you evaluate it, you get f prime of pi to equal exactly negative 1. In part B of this question, we are asked if k of x is the function h of f of x, find k prime of pi. All right, well, if k of x is h of f of x, notice that h of f of x is a composition, so I can find a rule for k of x, or k prime of x, by applying the chain rule. K prime of x would be h prime of f of x times f prime of x. Okay, so if I want k prime of pi, I need h prime of f of pi times f prime of pi. Well, I did just find f prime of pi in the previous question, but I still need to evaluate f of pi and then calculate a derivative of h at that point. K prime of pi would be h prime of 2 times negative 1. H prime of 2, if you check the graph of h of x, is negative 1/3. Negative 1/3 times negative 1 is positive 1/3. In part C of this question, we define another function, m of x, to be g of negative 2x times h of x. And we are asked to find m prime of 2. Notice that m is defined as a product of 2 functions, so in order to find a rule for the derivative of m, we need to apply the product rule. M prime of x would be g of negative 2x times h prime of x minus 2 times h of x times g prime of negative 2x. Kind of a mess, but we do have enough information provided to us where we can start substituting in values here. So if I want m prime at 2, I need g of negative 4 times h prime of 2 minus 2 times h of 2 times g prime of negative 4. Keep substituting in values when I can find them. M prime of 2 is 5 times negative 1/3 minus 2 times negative 2/3 times negative 1. Technically, this expression right here should be all you would need for this since all the calculus is done. It's all arithmetic after this. If you simplify all of this, eventually you do get negative 3. In part D, we are asked if there is a value of c in the interval from negative 5 to 3, or negative 3, such that g prime of c is negative 4, and to provide justification. All right, so this seems like a mean value theorem problem. So if we use the mean value theorem and just apply it on this interval, g of negative 3 minus g of negative 5, all over negative 3 minus negative 5, we get 2 minus 10 over 2, which is negative 8 over 2, which is negative 4. So we get the result that we want, but we have to justify using the mean value theorem in the first place. We are given that g is differentiable. So if g is differentiable, it's continuous. We are good to go using the mean value theorem. So by the mean value theorem, yes, there should be a value of c in that interval from -5 to -3, such that g prime of c does in fact equal -4. Right? You do need to verify that the conditions of the mean value theorem are met. You do not need to cite the mean value theorem specifically, but you do need to verify the hypotheses, which is that g of x is differentiable. And then you have to show the work that gets you the fact that, yes, something is -4 on that interval, and therefore g prime of c must equal -4 somewhere in that interval as well.